Let me see how many of you remember this formula, sine of a plus b. Do you remember the formula for sine a plus b?
Sine A cosine B minus cosine A.
No, it's plus.
Plus.
Pretty close, yes.
Close.
Yeah. And then sine of a minus b is just like the top, except that you're replacing b by negative b. And because cosine is even, cosine negative b doesn't change anything. On the other hand, if you have sine negative b, that does bring the minus outside, so you're going to have a minus here. Okay. How about cosine a plus b? Anyone? No. Cosine a, cosine b, and what do you think?
Is it minus?
Minus. What else can it be if it's cosine, cosine?
Sine A,
Sine a, sine b. And if you do cosine a minus b, again, cosine is even, sine is odd, so only this sign will change. So it'll be cosine a, cosine b, plus sine a, sine b. How do you prove it, though? Well, one way is to use geometry. You can actually you can start by taking this size 1, and then you have this point angle A, so that this point is cosine A comma sine B. And then you can take another size 1 on the unit circle. Let's say this angle is B. And then you can, let's say this angle is B. And then you can use like SOHCAHTOA and work with this. It's not so fun. You can verify that this is true, but it's not that fun. What's better is you can use Euler identity to find the, actually you can just find out this formula. Let's say you forgot these formulas, then you wanted to find it out yourself, then you can just use the Euler identity. Let me show you how that works. So first, e to the IA times e to the IB. Well, we know the exponential rule that if you multiply, this should be what? E to the?
E to the AB. E to the IA plus A.
IB. And then you factor the I out, and you get e to the I, A plus B. And then we know that e to the IA is cosine A plus I sine A. E to the IB is cosine B plus I sine B. And you can FOIL this. Let's FOIL it. This times this times that, this times this times that. And the result is you have cosine A, cosine B, plus I times cosine A sine B, plus I times sine A cosine B, plus if you have I times I, that's I squared, which is? Yeah, so it's going to be negative sine A sine B. And then you put the real parts together and then imaginary parts together. So we can write down cosine A cosine B minus sine A sine B plus the imaginary part will be, let's write this one first, sine A cosine B plus cosine A sine B. And then this has to equal to this one, but what is this? According to Euler's identity, this is cosine A plus B plus I sine A plus B, isn't it? So the real part has to match with this real part. The imaginary part has to match with this imaginary part. And therefore we've proved this identity and that identity. The secondary ones were simply replacing B by negative B. So it's done. Okay? So this not only gives you proof that these two are true, but when in case of emergency, you're taking an exam and you needed this and you just forgot, then you can just use this to figure out the formula yourself. It's kind of handy.